So today what we're gonna do is start chapter 8, and we don't do section 8.1. If you notice, we're starting with 8.2. Today's lesson is not gonna be bad because it's Pythagorean Theorem. And even though that's super important, we've done it a little bit so far in this class, so I think you'll do fine with it. You do need a calculator today, so if you don't have one, I have a couple on my desk that you can get up and go grab, okay? And again, by Friday, you need to have a graphing calculator if at all possible, okay? So borrow from the, did anyone go to the media center and try to check one out? So if you don't have one, go there, try to check one out and say that you're in advanced geometry and I said that you should do that, okay? All right, so today what we're gonna do is learn the Pythagorean Theorem. Pythagorean Theorem is something like, if you leave this class and you don't know how to do that, that means I've failed as a geometry teacher. It's so important. So when you have a right triangle that has a right angle, the side across from the right angle is called the hypotenuse. And then the two sides that kind of border that are called the legs. Okay, when you go to do Pythagorean Theorem, we call the hypotenuse C, and we call the two legs, bless you, A and B. And then what Pythagorean Theorem is A squared plus B squared equals C squared. So today I do want to see some work, and I'm gonna warn you guys, when I give the quiz on this, a lot of people will just get in the habit. They'll put the two sides today in for A and B every single time. And they'll just go, like say your two sides were 2 and 3. They'd go to their calculator, 2 squared plus 3 squared. And then, would you guys know you have to take the square root of it then, right? And then they take the square root of that. That only works if you're given your two legs. But oftentimes today, you're gonna be given a hypotenuse and one of the legs, and then you'd substitute the leg in for A or B, and substitute in the hypotenuse for C, okay? Now, let's go here and try one of these. So what we have here, across from the right angle is our C. A and B never matter. I usually have A be my X and B be the other side. And like I said, I do want to see some work for this. So A is X squared, B is 8 squared, and C is 12 squared, okay? Now, 8 squared is 64. 12 squared is 144. So this is an example of one where we're not just given the two legs. Now to solve this, I'm going to subtract 64, and I would get x squared equals 80, and then I would take the square root, and when you do that, you are going to get, if you do it on your calculator, you're going to get second square root 80, and that is 8.94. Now, 8.94. I do want to show you something else. This is something that you're going to learn more next year in Advanced Algebra 2, but it's possible you guys did this last year in algebra also. Did you guys talk at all about if you have the square root of something and they don't want you to just take the square root on your calculator, that you can look if there's a perfect square that goes into 80. And what I mean by perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. I'm just gonna keep going until I get to 80. 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, and then 9 squared is 81, which is bigger than 80, so we don't have to keep going on that. But what you do when you try to simplify a radical is you look if there is a perfect square that divides evenly into 80. So you would start with the one that's just less than it, because you want the biggest perfect square that goes in there. And you would think, does 80 divided by 64 give us a whole number? And it doesn't. Does 80 divided by 49 give us a whole number? And it doesn't. 80 divided by 36 would not. 80 divided by 25 would not. 80 divided by 16 actually does. So 80 divided by 16 is 5, okay? So what you can do there, once you figure out the biggest perfect square that goes in there, you can take the square root of that 16 and you can pull that square root out front, and your answer would be 4 root 5, okay? Did you do that in algebra last year? No? Okay. For today and for our class, first of all, I'd never try to do it this way if this number was bigger than 100, because otherwise it can be quite a lot. And in this class, you don't have to do that. If you wanted today to just take the square root and put it as a decimal, that is absolutely fine. But I just wanted to show you this because your answer book and the teacher's edition may show your answers that way, and I wanted you to just kind of see what they meant by that. But as far as which one you do, it's up to you. I just would not do it if it's a number bigger than 100. That can be a lot. Okay, so if we look at this one, across from the right angle is C. The other two sides are A and B. Doesn't matter which one you say is A and which one you say is B. And then if we do A squared plus B squared equals C squared, A is 4 squared, B is 7 squared, and C is X squared. Okay? 4 squared is 16, 7 squared is 49. So did you guys get 65? Okay. Then we have to take the square root of that. And then again, if you wanted to, you could check less than 65. Do any of these divide into 65? And I don't, like evenly is what I mean, so that you get a whole number. And I don't believe any of them do. So then you would, if you did it that way, you'd leave it as root 65, or you can go to your calculator and you can go square root 65 and get 8.06. And either answer is absolutely fine with me, okay? As far as work goes, I would want to see at least this step right here and then your answer, okay? So even if you just give me that, that would be nice. Now, one thing to keep in mind is you can only use Pythagorean Theorem in a right triangle, okay? So I never could do it for the outside triangle here. Say that 8 was an X, I can't do it. It only works if you have a right triangle. So I'm gonna use this. And then in this diagram, these two triangles end up being equal or congruent. So what that means then is these two pieces would be equal. So if they're each 8, these are 4. So what I really have there, you don't really have to rewrite this, but I will, is x, 4, and 9, okay? Then I'm gonna do my a squared plus b squared equals c squared. So across from my right angle is c. Then a and b don't matter, so I'm gonna say that's a and that's b. So I'm gonna go x squared plus x squared plus 4 squared equals 9 squared. So if you're punching that into your calculator, make sure that you realize you don't always just add them together and take the square root. So this would be x squared plus 16 equals 81. Subtract 16. And x squared would equal 65 again. These two just happen to be the same. So you could have left it as root 65, or like we got up here, 8.06. Okay. Then if I look at this one, this is going to have bigger numbers. My C is going to be this. This is my A. This is my B. So if I do a squared plus b squared equals c squared, a is 16 squared, b is 33 squared, and c is x squared. Okay? Now, those are harder to do in my head, so what I'm going to do is do those on my calculator. So if I do 16 squared plus 33 squared, that's 1345. So this is one I would not try to find and simplify. That would take you forever. So we're gonna go second x squared 1345. And that's 36.67. Okay. Now, if I look at this, I can only use Pythagorean Theorem for a right triangle. And if you notice here, I can just ignore the rest of that and just look at that triangle. Across from this is my C. I could say this is A and this is B. So if I do a squared plus b squared equals c squared, a is x squared, b is 14 squared, and c is 16 squared. Then 14 squared is 196. 16 squared is 256. If I subtract 196, okay, x squared would equal 60. And this is one that we could reduce the radical again because 4 goes into that. Okay, 4 goes into 60. So I could write that as the square root of 4 times 15. And then would you guys know how you'd write the final answer? 2 square root of 15. So it's like you take the square root of that and bring it out. Or you certainly could have just gone to your calculator and done square root of 60. But I just wanted you to see this, because that's something you're going to do a lot next year. Or 7.75. Okay. All right. Now if we go to this page. So there are certain right triangles that are made up of whole numbers, okay? All three sides are whole numbers. When that happens, those three sides are called a Pythagorean triple. If you look back here, these were different than what I'm showing you now, and how I know that is we got a decimal for our answer. So what I'm showing you on this next page does not work all the time, but there are certain right triangles, like one of them that I want you to remember for the future, when you have MCA tests, when you have your ACT test, if you take that, fast bridge, is the most common right triangle that has whole number sides is a 3, 4, 5. So if you took 3 squared plus 4 squared, that would equal 5 squared, okay? Now, in this chart, what they did is they took 3, 4, 5, and they multiplied all those sides by 2, and they got a 6, 8, 10 triangle, and that works also. Then they took and multiplied the original by 3, then by 4, then by 5, and so on. Now, my chart doesn't have all of them. I just included some of them, but you will have this and you'll use it on your test. So if you remember to look at that and you can tell it's a Pythagorean triple, you don't have to show any work at all, okay? Another super common one that I would like you to know is a 5, 12, 13 triangle. So these two right here are things that I would like you guys to just know, okay? Even if it was, and if there was one other I'd like you to know, it would be that one, okay? But what they did again is they took this and they multiplied by 2, 3, 4, and so on, okay? Now, how does this work? On the next page, they're gonna say, let me see what it actually says. Use a Pythagorean triple to find x. So when you see that they say use a Pythagorean triple, go to this chart. I can't guarantee everyone is gonna be on there because my chart is just made up by me. I don't have all of them on there, okay? But they're gonna give you something like this. They're gonna give you a right triangle, and they might say, this is 30, this is x, and this is 78, okay? What I would do if they give me the hypotenuse is I would just go to my table and find the biggest side that is 78, okay? Which is right here. So then look at this one and see, was one of the other sides 30? Yes. So then our missing side is 72. Do you get that? Is that easy enough? Okay. So let's go to this page. Here's our Pythagorean triple chart. Here's our first problem. So again, on these, we don't have to show any work. So they're telling me the biggest one is 26. So the one that has the biggest one that's 26 is this. So let's see if that works. It's a 10, 24, 26. So shouldn't this be 10 then? And that's all you have to do. Okay. Then if I look at this one, my biggest one is 39. So if I look for one that has 39, it actually happens to be right below that. And we have a 15, 36, 39. So this would have to be 15. Then if I look at this one, the biggest one is 15. So that gives me this right here. So it's 9, 12, 15. So that means this would have to be 12. Then if I look at this one, it's the biggest one is 40. So if I look down here for 40, here's one, 24, 32, 40. So 24, 32, 40. Now, all the examples I've done so far, and this one too, happens to give me the hypotenuse, but that's not always going to be the case today. So I do want to just show you quick after I get done with this one that doesn't give me the hypotenuse. But this one has 150 as the hypotenuse. So that would be right here, 42, 144. So this has to be 144. And then really quick, I just want to do one that doesn't give you the hypotenuse. So let's say that we had something that was 21, 28, x. Then it's harder, a little bit harder to do this because you don't just look at the biggest number. So here you're just gonna look, what's one that has 21 and 28? And that's this one. So my biggest side would be 35. That's easy, right? Everybody get that? Okay. Now what we're gonna do is go over a couple word problems and then we'll be done. So a really common word type problem with Pythagorean theorem is having a ladder lean against a wall, okay? So here, they're talking about a 20-foot ladder is placed against a building to reach a window that is 16 feet above the ground. So my window is up here, okay? I'll just say this is the window, all right? The ladder is 20 feet, so that is gonna go right here. And then it says that it reaches a window that's 16 feet above the ground, and we wanna find this, okay? So you can go back and look at your Pythagorean triple thing and see, is there one that your biggest side is 20? And there is, right here. So that tells me I have a 12, 16, 20. But keep in mind, so this is 12. Keep in mind, they're not all going to be Pythagorean triples today. If it's not on that chart, then you have to do a squared plus b squared equals c squared. So this says Damon is locked out of his house. The only open window is on the second floor, which is 12 feet above the ground. So again, we have a ladder problem, and it says that Damon's window up here again is 12 feet above the ground. Okay? He needs to borrow a ladder from his neighbor. If he must place the ladder 5 feet from the house to avoid some bushes, so this is where he places it away from the house, what length of ladder does Damon need? This was one of them that I'd like you to remember. Do you remember what it was? 5, 12, 13. So our answer is just 13 feet. If it was not on that table, then we'd have to do a squared plus b squared equals c squared. Okay? Then we can go to our last one. And here again, we have a ladder problem. And it says the distance from the base of a ladder to a wall that it leans against should be at least 1/4 of the ladder's total length. What is the maximum distance x up the wall? So what we're looking for is what is the maximum distance you can place that ladder up the wall that a 20-foot ladder, which is always going to be your hypotenuse, would reach to the nearest tenth. Okay, so here's what we have to realize. This one's a little bit harder. Okay, the distance that the ladder goes on the wall is going to be at least 1/4 of the ladder's total length. Do you guys know what 1/4 of 20 is? 1/4 of 20 would be 5, right? Okay. What happens here, you want to think, one way you can do it is if the 4's on the bottom, 20's on the top, you can divide each of these by 4. And then multiply, you have a 5 on the top, you have a 1 on the bottom. Okay? You could go 0.25 times 20 if you can't do that in your head. Now, the biggest side is 20, and one of my sides is 5. So if I look, I do have a biggest side that's 20, but I don't have a side that's 5 here. So what that tells me is I have to do a squared plus b squared equals c squared. So if I go back to that and do a squared plus b squared equals c squared, this could be my a, this is my b, this is my c. So a is x squared, b is 5 squared, and c is 20 squared. So that would be x squared plus 25 equals 400. Then you're going to subtract 25. And I would get x squared equals 375. And then I would do that one in my calculator. Okay, so we're going to go square root of 375. Which is 19.36 feet. All right, so your assignment for today, there is a worksheet and a little book assignment, I believe. So you're going to do these 2 problems in the book, and then there's a worksheet posted in Schoology. It tells you which ones to do on the top, and it's 2 sides, and I did put the key up on the textbook up there so you can check your answers, okay? So you're going to do both sides of that worksheet, the ones it says, plus these 2 problems on notebook paper.